Hello students, this is your Bhushan sir. We are going to continue the concept of non-conventional energy resources. In previous videos and classes, we have learnt about various types of non-conventional energy resources, which are nothing but new or innovative technologies by which the energy is produced. So in that regard, today we are going to understand nuclear energy and nuclear reactions. When we look at the atoms, these are the major building blocks of all matter, both of living and non-living. Atom is the fundamental building block of all the matter is what we discussed. And what we know consists of chemically a central nucleus made up of protons and neutrons, and surrounding which are the imaginary parts in which the electrons revolve. These protons are positively charged subatomic particles. Electrons are negatively charged particles, and neutrons do not have any electrical charge on it. The nuclear energy is the energy released by the change in the nucleus of an atom caused by either the reaction of nuclear fission or nuclear fusion reaction. We will have to remember here the equation of energy, where E is equal to mc square, where m stands for the mass, E stands for energy. So mass that has energy in it can be converted either into energy, or energy can also be converted into mass. The evolution of nuclear technology, that is, obtaining energy of the nucleus out, was given by Henry Becquerel in 1896, along with his associates. Nuclear technology is used for changing the nucleus of some specific elements, such as uranium, which releases the nuclear energy enormously. Nuclear energy is produced naturally by nuclear fusion process in the sun and other stars that release energy out in the form of heat, light, and even sometimes the radioactive radiations. The nuclear energy also is released by nuclear fission reaction. It is naturally seen in the decay of elements such as uranium again in the Earth's crust. It is also produced through man-made operations in the nuclear power plants and nuclear weapons. When we look at the scenario of nuclear energy around the world, it contributes to 14% of world's total energy of electricity form. USA ranks first, France ranks second, and around 31 countries makes use of this nuclear energy. The nuclear technology refers to the technology involved in the nuclear reactions of the atomic nuclei. There are two types of nuclear reactions. Number one, nuclear fission reaction. Fission means to split. So nuclear fission refers to process of splitting of nucleus of an atom into two or more smaller parts or lighter nuclei, and that also involves the release of energy and even neutrons. And this energy is in the form of heat or kinetic energy, and sometimes even in the form of electromagnetic radiations. Nuclear fission reaction takes place in heavy metals, and it is an exothermic reaction, meaning to say heat is expelled out. They also produce free neutrons, gamma photons, and enormous amount of energy. So this nuclear fission reaction that takes place in heavy metals can be achieved in an artificial manner, that is man-made process, by bombarding the nuclei with slow-moving neutrons. The nuclear fission reaction includes, let us consider, K is the total number of neutrons released per nucleus. If the value of K is greater than 1, then the reaction releases more neutrons than it absorbs. Hence, it's called as self-sustaining chain reaction. Students, remember, we know nuclear fission reaction releases out neutrons if the number of neutrons released per nucleus is considered as K. If the K value is more than 1, then the reaction is called self-sustaining chain reaction. This was first used by human beings in the development of atomic bomb on the eve of World War II. Different nuclear fuels used in the nuclear reactions includes uranium-235 and other fuels. Nuclear fission reaction of uranium atom. When we look at uranium, is a naturally occurring element which is available in the form of isotopes of uranium-235 and uranium-238. Uranium-238 is available around 99%, and uranium-235, that 1% what it corresponds to. When this uranium-235 absorbs the slow-moving neutrons, the process of nuclear fission reaction takes place, relating to the formation of smaller nuclei with energy and neutrons further. So here is the picture down which depicts the process of nuclear fission reaction. The products of nuclear fission of 235 varies, and the neutrons which are released here involves in a chain of reaction to continue until the fuel is completely spent. The second reaction is nuclear fusion reaction. Fusion here refers to a reaction of two or more lighter nuclei that joins together to form one larger or heavier product. So it is a vice versa reaction of nuclear fission. In nuclear fission, larger nuclei will break into smaller units. In nuclear fusion, smaller nuclei will fuse to form larger nucleus. So the products during this process of nuclear fusion reaction includes, again, the subatomic particles like protons, neutrons, along with the release of energy. The nuclear fusion reaction naturally occurs in the sun and even in most active stars of the universe and even in the solar system. Nuclear fusion reaction is an exothermic reaction which releases enormous amount of energy, and that's the reason why the sun, which shows the nuclear fusion reaction in it with the help of hydrogen nuclei that combines to produce helium, will release lots of energy which comes out in the form of either heat or light and even electromagnetic radiation that strikes the earth. Nuclear fusion reaction is also utilized for the production of hydrogen bomb for the destructive purposes. Coming on to nuclear power reactors. It's a device used to initiate, control a self-sustained nuclear chain reaction. It's a device system where the reaction of either nuclear fusion or nuclear fission takes place in a controlled manner. It produces the controlled energy which is released out from the uranium nucleus. This energy in the reactor is used for heating of the water to form the steam, and this steam is allowed to run the generator that produces electricity. So the very purpose of nuclear reactors is to generate the electricity. A nuclear reactor will have the following important components. Number one, nuclear fuel. It is an element used for the process of nuclear reaction to take place. It includes uranium-235 or plutonium-239. The second part is the moderators. Moderator is used to reduce the speed of the fast or slow moving neutrons. The next, it includes control rods. These are the neutron absorbing materials which are used in the nuclear reactors. Boron, silver, cadmium, indium and other materials are used as the control rods here generally. The next one is the coolant. It's a liquid or a gas which transfers the heat obtained in the process of reaction into the external boiler, and that heat is utilized for the production of the steam, and the steam is utilized further for running the turbines that will produce the electricity. The next one is the steam generators. The steam is generated by using the heat from the reactor system. The next is the shield and containment system. As it indicates, it is the outer jacket of the covering, which is several meters thickness, which will keep the radioactive gases and liquids inside the reactor and protects those outsides from the effects of radiations. Coming on to the applications of nuclear technology. It is used for production of electricity predominantly. It is also used, to say the electricity is also used in many industrial purposes such as plastic manufacturers, the sterilization of disposable products, etc. They are also used to produce the nuclear weapons to strengthen the security of a country. Then it is also used in the form of radiotherapy for the treatment of most malignant tumors. Nuclear technology is also used in the agricultural field to control the pests and insects. Coming on to the risk of nuclear accidents. A nuclear and radiation accident refers to an event that has led to the significant consequences to the people and environment, or even to a facility. In simple terms to say, it is the adverse effects caused by the accidents of the nuclear reactors. Example, it includes lethal effects to the individuals, radioactive isotopes to the environment, or even reactor core melting process. Over 17,000 cumulative reactor years of commercial operation is seen in 33 countries, but so far only 3 noted nuclear accidents were witnessed. It includes 3 Mile Island of the US in 1979. It is due to the severe damage caused within the reactor. Then Chernobyl of Ukraine in 1986, when the destruction of the reactor by steam explosion was seen, and many people were killed during this explosion. And Fukushima of Japan in 2011, where the reactors were subjected for control or stoppage of activity due to huge tsunami. This also has led to accident of nuclear reactor and killed around 19,000 people. The risk of nuclear accidents, it includes effects on human life, birth defects, that is, by birth the deformities are seen in the newborns, cardiac problems, genetic disorders, then arthritis related to the bones, allergy, anemia, then cancers related to the skin, blood, breast, cervical, colon, lungs, ovary, prostate glands. They also cause hormonal disorders. For example, iodine 131 and cesium are more damaging. We know that iodine is actively taken up by the thyroid gland to make hormones. When iodine 131, which emits the beta particles, is taken up by the cells, they damage the DNA and cause the thyroid cancer. They also cause severe effects on the environment also. It includes increase in environmental temperature. Then nuclear accidents will cause global warming. They disturb the ecological food chain, destroys the flora and fauna, pollutes the water bodies excuse me, and soil. Advantages of nuclear energy when we look at. It does not emit greenhouse gases like carbon dioxide, thus cause no global warming. It do not release chemical pollutants and even soil pollutants. It releases more energy per unit of fuel. It is seen that if we could burn 1 gram of coal and 1 gram of uranium, 1 gram of uranium will release 250 million times of energy as that of the coal. So that huge, enormous energy is released by the nuclear fuel. And this nuclear energy doesn't require a very large area for the setup of nuclear reactors. The maintenance cost is also very cheaper. The disadvantages includes the waste production after the nuclear energy production is called radioactive waste. This radioactive waste will have the radioactive power for thousands of years, so they remain in the active condition. So to throw them or to dump them, the site problem is as same. Then setting up of the nuclear power plants is a very tedious process because we need to get a clearance and approval from the governments of state and the central. Then the nuclear power plants also pose threat to the nuclear accidents, which will cause the damage to the surrounding people and even the life. The construction cost of nuclear power plants is very expensive. So to summarize, the energy resources of non-conventional energy types, it includes nuclear fuels, then water, tidal energy, solar energy, geothermal energy, then wind energy, hydrogen as future fuel, biodiesel, biogas, etc. All these components of non-conventional energy types together is important for the 10 marks question or a major question, and each one of them is asked for the short notes. Students, please write your comments and critiques to my WhatsApp number. I wish you all a very good day ahead. Thank you all.